See, this is gated SR I told. Gating is what? Gate, it is something has been applied as a gate here. If I open the gate, then only the signal flows. If I close the gate, then whatever may be the inputs I am applying from the other way, it will not affect. Right? So that's what the enable is doing here. I have my S bar R bar latch. To that S bar R bar latch, I have added one more stage in which I have two more NAND gates. One terminal of the NAND gates are applied to my S and R input, and another terminal of the NAND gate has been connected to the enable gate. Now, if my enable bit is 0, then whatever I input I apply at S and R is not having any effect on my output. Why? Because when my enable bit becomes 0, so both 1 and 2 NAND gates will go to the high stage, and high stage of this gate shows that my S bar R bar is in the no change state. So whatever may be the input I apply, my output will be in the no change state. It means what? Even though I have applied the inputs S and R, that won't make an immediate change in the output. And if I want that if I want the output to be changed, I even has to activate my enable bit. If enable bit is 0, then I call enable is deactivated, disabled. The enable bit is disabled. If I make the enable bit is 0, then whatever the input I am applying with S and R, that is not giving any output. I mean, that is not changing my output. So there is no response to the input I have applied. Now, if I make my enable bit is equal to 1, then what happens? If enable bit is 1, now the control goes to S and R. Now I have to look at the another input. When enable bit is 1, then I have to look at the another input. So what is that I have to check now? Now I have to check my S and R. See, now let us see that my S bit is 0. I have made my S bit is equal to 0 and R bit is equal to 1. Okay, when S is 0, this is 0, 1, making my output to be in a high stage, and this is 1, 1, making my output to be in a 0 state. Correct? So this is leading to 1, 0 here. So when this is 1, 0, my S bar R bar is 1, 0. Tell me which condition I will be. S bar is 1, R bar is 0. So I will be in 0, 1. That is the reset stage. So what happens to my output Q and Q bar? It will go to 0, 1. That is reset stage, right? See, my set bit is 0. So output is also, so this is an active high logic. When my set bit is 0, I have to look at the input of this, not this. This is an intermediate input. This is the input I am applying, S and R. So when my S is 0 and R is 1, my output will be 0, 1. So it will go to the set condition. So it is same as the SR function table. So I have written S and R here, and Q and Q plus and Q bar plus here. So this is the function table I am writing. So when my inputs are 0, S is 0 and R is 1. I got my output also as 0, 1. Now let us see what happens when I have one more input here now, that is called enable. If enable is 0, then whatever the input I am applying, I will be in the no change condition only. So I call it as a no change. When my enable is 0, see I have written X, don't play here. Whatever may be the inputs I am applying here, my output remains in the same state. That's a no change state. Now, when my input is 0, 1, then output is also 0 when my enable bit is high. Now let us see what happens if I make my set equals 1 and reset is equal to 0. If set bit is 1, reset bit is 0, then what happens? My enable is 1, so both of them are 1. So this goes to 0 stage and this comes to 1. So this 0, 1, what happens? When my S bar is 0 and R bar is 1, then I will be in a set state. So what happens to my output? My output will be 1 and 0. So if I try to look into the function table of my S bar R bar, so this is 1. So enable bit is 1, my S bit is 1, R bit is 0. So I mean 1 0 state. So it is nothing but set state. S is also in a set 1 and output is also 1. So it's a set state. Now if I make both the inputs as was 1 0, now if I make both of them as 1, then what happens? Enable is also 1, this is also 1. So both of them will go to the 0 state. When both the inputs are 0, then in which condition I will be? I will be making both of them as high, which is an undeterminate state. So when enable is 1 and both the inputs are high, then I will be getting 1 1 here. So which is nothing but my indeterminate state. Now if I make both the inputs as 0 0, then what happens? Enable is 1, 0 1 0 1, make both of them to go to 1 state. Both the inputs are in 1 state. When both the inputs are in 1 state, according to my S bar R bar latch, it should be in an unchanged condition. So whatever the previous input I will be having. Suppose if my previous input is 0 1, then I will be having same thing. When enable bit is high and both the inputs are 0 0, again I will be having the same thing. I will be in a no change condition. Right? So this is gated SR latch. So gated SR latch is a positive synchronous SR latch. If I just talk about a SR latch, then it's a positive asynchronous SR latch. Whereas gated SR is a positive synchronous SR latch. Yes, any doubts with it? Any doubts? Okay. If you don't have any doubts, then I'll just show you one more class of latch. See, this is an SR latch, correct? Now, in this SR latch, if I tie these two inputs and give it as a one single input, then I call it as a D latch. Just remember this. In gated SR, if I tie these two inputs and connect it to one input, then I call it as a D latch. Okay. What is D latch? We'll see it in the next class. Any doubts?